So for this video, we're going to go back to the example that we used in the last one. What is the slope of y equals x squared at x equals 2? We already estimated it using, I can't remember what the answer was, I think it was 4. So now let's find out what it actually is. Well, let's do our limit definition. So the limit as h goes to 0 of f of x, well, 2 in this case, we'll use our specific case, 2 plus h minus f of 2 all over h. Well, whenever you say f of 2, all you're doing is plugging in 2 into the function x squared. You plug in 2 and you get out 2 squared, which equals 4. So when you plug in 2 plus h, you get 2 plus h squared. Because the function was x squared, and in place of x, we wrote 2 plus h. So what's 2 plus h squared? Now, remember, it's not 2 squared plus h squared. A lot of people make that algebra mistake, but if you were to actually expand it out, you would get 2 squared plus 2h, plus, actually, you would get 4h, plus 4h plus h squared. And 2 squared is 4, so I'll just write that as 4. I'm just kind of showing the pattern for how you write those out. So 4 plus 4h plus h squared. Now what's f of 2? Well, and I'll go to the next page. Just remember that it's, I promise I'm not lying, 4 plus 4h plus h squared. Whoops, it's supposed to be an h. Plus h squared minus f of 2. Well, f of 2 is 4. So 4 cancels out. You're left with over h. Well, we can factor out an h from the numerator that's left. So h times 4 plus h all over h. All over h. That cancels. Simplifies down to 4 plus h. So now remember, it was a limit. So the limit as h goes to 0 of 4 plus h is equal to, well, remember this is like that first type of limit we ever saw where you can just plug it in. That 0 goes in for h. So we're going to get 4. That h just straight up disappears. So the limit as h goes to 0 of f of x plus of f of 2 plus h minus f of 2 all over h is 4. So the slope at that point is 4, which means that our estimate initially was right on. That was just lucky, though. Usually you're going to be off by a little bit. That was just a special case. Now, I guess the next thing to do is to try it on a different case, maybe a different kind of function, or however, I'll leave that for your actual class, or maybe some problems that you'll have in homework or that you're going to do on your own. Once again, this you're not meant to just watch this and master calculus. So that's an example of how it worked in this simple case, and you'll see, luckily, you don't have to do that whole rigorous limit proof every time. There's a simple pattern. Just to give you a hint about what the one is for this type of function, if you'll notice, the function we were working with was x squared, and we wanted to know the slope at 2. Well, it just so happens that the value is 4. You can't, obviously the slope is not just the value of the function, but I'll give you a hint that the slope of this function, the slope, or another way to say it is to take the derivative. That's some notation that we'll go over next video. The derivative of this is equal to 2x. So maybe you've seen the pattern in your class or you know what it is, but the derivative of that is 2x. Then we plugged in 2. 2x evaluated at 2 is equal to 4, which is the number we got. Next video we will go over some rules of differentiating and whatnot, but basically we saw the definition of what a derivative is in this video, and we'll move on next video.